All right, so far we've been talking about quadratic equations as equalities, right? With this y equals ax squared plus bx plus c. But oftentimes we are also interested in inequalities, whether it be greater than, less than, greater than and equal to, less than and equal to, or a combination of different equations. So this should be a short video. Just want to show you some graphs of uh, graphically, how do these inequalities appear? I think they are relatively intuitive, but it's useful to see how they come about. And you can imagine these inequalities in more elaborate equations, like combinations of quadratics and linear equations. And we'll look at application problems in future videos where these quadratic inequalities are important. And we'll see the different combinations that do arise and graphically how we can show these. Here we have our generic equation y equals x squared. We can use this line as a reference point. When we say it's greater than x squared, we're shading everything above the y lines here, right? So this line represents my y equation. So all y values above it at a given x value, which is basically anything above this line, is shaded in. Conversely, if I say less than x squared, I can shade in at any x location on that line, shade in everything below it, and that's why it's shaded here. I'm not showing the graphs here, but I don't know how well it comes out in the video, but the line that represents y equals x squared is a dash line because this is an inequality. If I wrote y greater than or equal to x squared, the line will be solid, so it would include the y equals x squared component. And similarly for y less than or equal to x squared, that could also have a solid line here too. I could combine different inequalities together, right? So let's say I have y equals x squared shown in black here, and then I add y equals 2x squared shown in red here. And if I look at y is greater than 2x squared, it's the area shaded above the 2x squared curve right here. Similar idea of y is greater than x squared. And then if I'm interested in the area in between these two lines, then I could just call it y is greater than x squared, which is this blue shaded, and y is less than 2x squared. So less than 2x squared will be everything except for this red line. So the combination of the two, right, if I stack this on this and just subtracted the two, then I will have this blue shaded area, right? So we will look at some applications in future videos where something like this comes into play. And here I'll show you another example. We have y equals x squared again shown in black, y equals negative x squared plus 3, just a negative, so something with a maximum value, and shift it up so we have a shared area here. If I say y is less than negative x squared plus 3, at every point here we're shaded downwards. That's why it's this area down here. Similar, kind of like the reverse idea of y is greater than a positive x squared term here. And if I want to share this combination area here, what do you think the inequality would look like? Well, it would be y is less than negative x squared plus 3, right? So this red shaded area, and y is greater than x squared, this blue shaded area. So only place where both are true is this shared space in the middle, and that's what's shaded in blue over here. You can see different combinations that might appear. There might be an or statement. There might be a linear equation, like a y is equal to an x term that's shaded with an inequality as well. And so there'll be all kinds of combinations because you're looking at different physical systems. So in engineering, understanding where these inequalities appear and how to visualize it graphically is an important skill. So a quick video just applying some of the things that you already have learned with a slight twist, just putting inequality or combination of inequalities to existing equations.